In this lesson, mole to mole, we are going to discuss mole ratios in a balanced equation. First off, our objectives are we need to understand that coefficients of a substance in a balanced equation represent the mole ratios of those substances. We are also going to use mole ratios from the balanced equation to calculate moles of other substances in that reaction. So let's consider the Haber process here. The Haber process is a famous process invented by Fritz Haber in order to synthesize ammonia, which is NH3, from nitrogen and hydrogen. So we all know that the balanced equation for this is 1 nitrogen molecule plus 3 hydrogen molecules make 2 ammonia molecules. So that represents the mole ratio. So the coefficients, remember, are in front. So the 1 is a coefficient, the 3 is a coefficient, and the 2 is a coefficient here. So that represents how many moles of each. So we can get 1 mole of nitrogen reacts with 3 moles of hydrogen, forming 2 moles of ammonia. So let's say I have a question. I want to know how many moles of hydrogen are needed to react with 0.5 moles of nitrogen. What we can use is the balanced ratio problem approach, BRP. B stands for balanced, R stands for ratio, P stands for problem. So up here we have the balanced equation and our actual ratio, which is kind of like our recipe for ammonia. And now we have in the bottom, in the P section, we have what we have in that problem. So we have 0.5 moles of nitrogen, and then we want to make sure everything's in the same ratio. So we have 1 to 3 to 2 is the same as 0.5 to 1.5 to 1. So we can answer and we can say, okay, well, I need 1.5 moles of hydrogen to react with 0.5 moles of nitrogen. What if we needed to do a different amount? Let's use the balanced ratio problem approach again. So instead of reactant, we want to produce 0.2 moles of NH3. Now to keep everything the same ratio, well, you might notice that 0.2 is 1/10 of 2, so it's going to be 1/10 of the other ratios as well. So I need 0.1 moles of nitrogen needed to produce 0.2 moles of ammonia. So let's try this example right here, and if you guys want, you can do it in your notebook. How many moles of CO2 can be made by reacting 4 moles of C3H8? I have my BRP right here. So you can find that we require 12 moles of CO2 to react can be created by 4 moles of C3H8. What if we have 2 different amounts? What if I'm a bicycle maker and I know that 2 wheels plus 1 frame makes 1 bicycle? The equation for that would be 2W, that's these wheels, plus 1 frame, that's this thing right here which I drew, makes 1 FW2. And FW2 is a frame with 2 wheels put together. But if I had 6 frames and 4 tires in my bicycle shop, how many bicycles could I make? So what we want to do when we have a problem where we have 2 separate amounts of reactants, in this case we have 6 frames and 4 tires. Now I have 2 BRPs, balanced ratio problem approaches. So I have one with 4 wheels and I have one with 6 frames right here. So I need to figure out which one works, and I can do those as similar as I did in the past. And I have 4, 2, and 2, and 12, 6, and 6. But I have 2 separate answers. I can either make 2 bikes or 6 bikes. Let's think about that with this molecular model. If I had 6 frames and 4 tires, well, I can only make 2 bicycles. Because after I've reacted those tires, I'm not going to have any tires left. That's why we call tires the limiting reagent. Because after they run out, we're not going to have any tires to react. We're just going to have excess of the other reactant. So when we do this, we figure this out. We look at my one of these two ratios is true, and since wheels are my limiting reagent, I'm going to be making the one with the fewer product here. So in the first case, A up here, we can make 2 bikes. In the bottom, we make 6 bikes. Now, I can only make 2 bicycles, so I'm always going to pick the one with the least amount of product. So, and I'll just have extra frames too. So if I started with 6 frames, I use 2 frames, I have 4 extra frames in the end. So, and I can only make 2 bicycles. 2 bicycles can be made. That's an FW2. So let's try another one. How many moles of ammonia can be made with 6 moles of hydrogen and 4 moles of nitrogen? Now, we know that it's going to be a BRP problem, a 2-1, because we have 2 separate amounts. We have 6 moles of hydrogen and 4 moles of nitrogen. So I'm going to do one with 6 moles of hydrogen and one with 4 moles of nitrogen. And I keep my ratio. My first one on the top, I have 2, 6, 4. My bottom one, I have 4, 12, 6. One of these is true. And it's, again, the top one. So I am only going to make 4 moles of ammonia because I don't have enough of the other reactant. I don't have enough hydrogen to, I don't have enough hydrogen to react to form more ammonia here. I'll just have extra nitrogen. Just like if you're making a sandwich, you're not going to use all the bread in one sandwich. You just take the 2 pieces that you need in order to make it. So, if you guys want, you can get a head start on the warm-up. Now, the warm-up here is this problem right here. We're going to do this as a warm-up next class. So if you want to get the head started, at least write it down. That's fine. Otherwise, we'll go over it in class tomorrow. And we'll talk to you guys later.